So welcome to today's lesson, energy resources and electricity generation. So there's two learning objectives. You have to understand the energy transfers involved in generating electricity through a range of different energy sources. And then a triple award learning objective, describe the advantages and disadvantages of methods of large-scale electricity production from various renewable and non-renewable resources. So the first we've got to work out what a renewable or a non-renewable energy resource is. So essentially a renewable energy source is an energy source that does not run out. Okay, so for example, wind, solar, geothermal, whereas fossil fuels such as coal or oil are non-renewable energy sources because they do run out. You run out of coal, you run out of oil because they're finite. So the first energy source we're looking at is wind power. So essentially with wind power, what you're doing is you're converting the kinetic energy of the turbine as it spins in the wind into electrical energy via something called an electrical generator. It's known as wind power. The advantages of wind power is it's renewable, it doesn't produce CO2 or water vapor or sulfur dioxide, so greenhouse gases. It doesn't cause acid rain because again it doesn't form sulfur dioxide. There's no radioactive waste. It's quite inexpensive to build. It's a short stand-up time, so it doesn't take much time to produce the wind turbines. However, you need wind. That's a disadvantage, which means you have to basically pick an area which has lots of wind, and people do complain about the look of the wind turbines. They bring property prices down. You need to have a large number of wind turbines to get sufficient amounts of energy. There's the noise associated with it and also the bird death that can occur when birds go through the turbines. They die. Then we have hydroelectric power. So what you're doing is using the gravitational potential energy of the water as it falls down, and that turns a turbine, so kinetic energy, which is then converted into electrical energy again through an electrical generator. And that's an example there of a hydroelectric power station diagram. Okay, so you've got water behind a dam, you release the gate, and then that water goes down a slough through the turbine, which turns, and then that creates electricity. So the advantages of hydroelectric power is, again, it's renewable, no greenhouse gases, doesn't form carbon dioxide, again, doesn't form sulfur dioxide, so there's no chance of acid rain, there's no uranium involved, so no radioactive waste, and it's again a short startup time relative to other methods. You basically have to have an area with lots of rainfall. Okay, so for example, there's quite a lot of hydroelectric dams in Borneo because it rains a lot there. You're going to destroy the environment a little bit, or a lot, because you're going to flood river plains, so it's going to affect the wildlife, and it's quite expensive to actually initially build. Then the next one is wave power. So again, what's happening is that the kinetic energy of the wave as it goes up and down is converted through a generator into electrical energy. Okay, and again, the advantages are it's renewable, there's always going to be waves. There's again, the greenhouse gases aren't formed, there's no acid rain, no radioactive waste. You don't need any land because it's in the ocean. And again, it's a short startup time. You just put in the wave generator and you're off. Wave strength can be unreliable, however. You have to have an area where there's lots of wave motion and action. If there's a storm comes in, you can have your wave generators destroyed. You need to have a lot to get sufficient amounts of energy, and there's a danger to shipping it because boats can smash into your wave generators. The next one is tidal power, not to be confused by wave power. Okay, so basically what happens is that as water moves in and out of a tidal zone, it can basically move through a turbine, and it can then generate electricity. So you've got the gravitational potential energy of the tide as it moves in and out. That's converted into a kinetic energy as the turbine moves around, and that's converted through a generator into electrical energy. So this is essentially how it works. Okay, as you can see, the tide comes in, it goes through the turbine, and also the bonus is as the tide comes out, it also goes through the turbine. So you get that double up of electrical energy generation through the generator. So again, the advantages are renewable. You're always going to have tides. Again, there's the no greenhouse gases, no acid rain because there's no sulfur dioxide formed, no waste from radioactive isotopes because none are involved. And again, it takes not much time to actually set up the process. Disadvantages are that you need to have a very strong tidal current. So it's only really available in certain areas of the world. It will again cause problems for wildlife, especially the fish that move in and out with the tidal flow, and it's very expensive to build. Then we have geothermal energy, which is quite popular in my country, New Zealand, and also in Iceland. So basically what happens is that you've got the thermal heat energy from the captured gas from underground volcanic areas, okay, the hot water, and that is pushed up, it turns the turbine again, and that turbine is converted into electricity through a generator. So again, the advantages are renewable. You're always going to have that volcanic activity, and there's no greenhouse gases, no sulfur dioxide, no radioactive waste, and again, it doesn't take much time to actually build the station. But it's very limited in locations. It has to be only locations where there is volcanic activity, like New Zealand or Japan or Iceland, and it's very expensive to build initially. Okay, then we have solar heating, which is quite popular in the US. So heat energy from the sun is basically focused onto pipes containing water. That turns into gas, which moves the turbine, and then that's converted into electrical energy through a generator. The advantage is it's renewable, the sun's always going to be there, there's no emission of gases, there's no radioactive waste, but problem is you need areas where there's quite a lot of sunshine. So for example in the US in the deserts would be a perfect example, around Nevada and New Mexico. You can only use it during the day because the sun's only out during the day, and you need a large amount of area to set up the arrays of the mirrors. Then we have solar cells. So basically what's happening is that the light energy from the sun is being converted directly into electrical energy, okay, through solar panels. Again, the sun's always going to be there, so it's renewable. There's no gas emission, there's no isotopes involved for radiation, and you're basically good to go. As soon as you have the cells, you're good to produce electricity. But again, you need sunshine, so you need the sun. Only works during half a day because only when it's sunny. It only converts about 10% of solar energy into electricity, so it's quite inefficient still, and many cells are needed to produce sufficient amounts of energy. Then we have fossil fuels, which are non-renewable. Okay, so fossil fuels are your coal, your oil, your natural gas, and basically they're caused by the decomposition of animal life and plant life over millions of years. And basically what happens is you're burning the fossil fuels to turn a turbine, again, which is then converted to electricity through a generator. And this is an example of a coal-powered fire station. So you can see that you're burning the coal, which produces a gas, which turns the turbine, and then that is converted into electricity through a generator. Okay. The problems with fossil fuels are you've got the carbon dioxide formation, which is a greenhouse gas, links to global warming, also produces sulfur dioxide because sulfur is an impurity in the fossil fuels, and sulfur dioxide can form acid rain, and also fossil fuels are finite, they're going to run out. So it means that it'll probably be about 200 years time there'll be no more fossil fuels to burn to produce energy. That's why we're using looking for alternative sources of energy through the renewable resources. So the advantages are you've got a concentrated energy source, it's reliable, can be built anywhere, and there's again no reactive waste. However, it's non-renewable, the fuel source. It produces these greenhouse gases and also produces acid rain, okay, which is sulfur dioxide being formed. Then we have nuclear power stations. Okay, so basically what happens is there's a reaction, a nuclear reaction, which forms heat. That nuclear energy formed into heat, which is then used to heat water, which turns turbines, which is then generated into electricity through an electrical generator. And this is a nuclear reactor here, so you've got the uranium fuel rods in the middle. As the reaction goes on, it heats water. That water is then used to convert it into steam. That steam turns the turbines, and that is then generated into electricity. Now, the problem with nuclear power stations are that even though it doesn't produce greenhouse gases, and it produces a massive amount of energy, the problem is that they're radioactive waste. So waste management is a problem. So for example, here we have in Chernobyl, where the reactor actually melted down, and that caused a large number of deaths. So the advantages are a very concentrated energy source. Lots of energy is produced. It's reliable. Can be built anywhere. Again, there's no greenhouse gases and no acid rain. However, uranium is not a non-renewable fuel source. It creates radioactive waste, which is hard to get rid of. It's expensive to build, and also the technology can be used to make nuclear bombs. So, for example, the Iranians and North Koreans are using possibly the technology to make nuclear weapons. So just in summary, this is the electricity generation pie chart. So most of our electricity is still being used by burning fossil fuels from gas and coal. Nearly 20% of the world's fuel is through nuclear, especially in France, for example, and less than 5% is from renewable sources. So it's our job to try and transfer from non-renewable fuel sources into renewable fuel sources. And that's essentially a summary of energy production.